If you look through the PowerPoint, you'll notice that I gave a whole description as to how to find a formula for work. And following the pattern that I mentioned at the end of the last video, you're going to see a lot of integrals of f dot dr being used as a formula for finding these line integrals. So here's a formula that involves force, right? This force field is xy on the path consisting of two line segments. Now I'm going to do one of them, and then you can work through the other one, because it's going to be a two-part problem. So one of the line segments goes from -1, 0 to 0, 8, and then the second part goes from 0, 8 to 2, 8. So the second part keeps the y's the same and changes the x's, so it's a horizontal line segment. All right, what are our formulas that we have? Well, we know what the force of the vector field is. The vector field is xy. What we need is r of t, which is a line segment that we don't have. So now we've got to go back to that r sub 0 plus vt. The line segment went from -1, 0 to 0, 8. So it went 1 unit to the right and 8 units up. So how do we write a vector that goes 1 unit to the right and 8 units up? Just like that. The initial point that was given was -1, 0. So r of t, the x is going to be -1 plus t. The y is going to be 0 plus 8t. All right, so now I can fill in the blank over here. R of t is going to be t minus 1, 8t. Well, when we do the dot product, we need f dot dr. So the derivative of that, the derivative of t minus 1 with respect to t is just 1. The derivative of 8t is 8. Then our f in terms of t's is going to be, well, exactly what we had before, t minus 1 and 8t, right? T minus 1 is the x-coordinate, 8t is the y-coordinate. Our vector field was boring enough that it was just xy. So now when I do f dot dr, I'm going to end up with t minus 1 times 1 plus 8 times 8t, which is 65t minus 1. Now we have to integrate that. Well, our limits of integration are going to be from 0 to 1, because if I go back to this step over here, put a 0 in for t and I get -1, 0. Put a 1 in for t and I get 0, 8, and those are the two endpoints of my segment. So I'm going to integrate from t equals 0 to t equals 1 of 65t minus 1 dt. And so that'll give me, what, 65t squared over 2 minus t. If I put in a 1, I'll get 65 halves minus 1, so 63 halves. Okay, so that's part 1. And then do the part from 0, 8 to 2, 8 and add them together. All right, so work can also be found by doing the integral of f dot dr. All right, circulation and flux of a vector field. Circulation tells you how much the vector field is pointing in the direction of the curve. So now you not only need to know the curve, but you need to know which way the curve is going, so you can tell me how much the vector field is pointing in the direction of the curve. Circulation is calculated with a line integral. Okay, so it says that the circulation is the integral of the dot product of f and t, where t is a unit tangent vector consistent with the orientation. So it matters which direction that curve is going. Right, let's take a look at this example over here. So I said, based on the picture, make a conjecture about whether you think the circulation is positive, negative, or 0. So the curve is going this way, right? There's the direction, so the curve is going that way. So those blue vectors, do they seem to be mostly going in the direction of the curve, right? You got some on the right side over here that are definitely going in the direction of the curve. You got some vectors on the other side that are definitely pushing against the curve. You've got some that are going outward from the curve up. You got outward from the curve down. Look at the lengths of the curve. Look at the directions of the curve. Do you think that as much is pointing in the direction of the curve as is pointing against the curve? Okay. Take whatever idea you have, and then I'm going to actually calculate the circulation. So the circulation is calculated again with an integral of f times r prime. So what is our f? The f was given to us right over here. R is also given to us. So that must mean then 2 cosine t is x, 2 sine t is y. So let's rewrite f in terms of the x and the y. I'm going to slide over here. That means that the vector field in terms of x and y is 2 sine t minus 2 cosine t. That's my first coordinate. And then my second coordinate is 2 cosine t. What is the derivative of r? Well, the derivative of cosine is negative sine, so I'll get negative 2 sine t. The derivative of sine is cosine, so 2 cosine t. Looks like I'm going to have to integrate this from 0 to 2 pi in order to go all the way around that circle. So when I do the integral of f dot dr, I'm going to get the integral of 2 sine t times that whole first term. So I have to distribute. Negative 2 sine t times 2 sine t is negative 4 sine squared t. Negative 2 sine times negative 2 cosine is positive 4 sine t cosine t. And then the last two terms, when I multiply those, will give me a plus 4 cosine squared t. All right. Well, I can actually pull a 4 out of this whole thing. And maybe even separate this a little bit. Let's take a 4 out of here. And I'll do the negative sine squared t plus cosine squared t first. And then I'll add 4 times the integral of sine t cosine t dt. I'm going to work this whole thing out because I think it's worth it to see the answer at the end so that you know whether you were right or not in your guess. If you get a positive answer, a negative answer, or a 0, that'll answer the question. All right, first of all, I need conversions for these sine squares and cosine squares. So I know that sine squared theta equals 1 minus cosine 2 theta over 2. So I'm going to get negative 1 minus cosine 2 theta over 2. Cosine squared is exactly the same thing, but with a plus sign. So 1 plus cosine 2 theta over 2, that's the replacement. So let's expand this out. I get negative 1/2 plus 1/2 of cosine 2 theta plus 1/2 plus 1/2 of cosine 2 theta. So the halves cancel out, and I end up with 1/2 plus 1/2, which is 1. So I get 4 integral from 0 to 2 pi of cosine 2 theta d theta. Right, this second one over here is going to give me a u substitution. So let u be the sine of t, and then the derivative of sine is just cosine t dt. So this gives me 4 times the integral of u du, and now I need new limits of integration. So instead of it going from 0 to 2 pi, the sine of 0 is 0. The sine of 2 pi is also 0. Oh, look at that. How convenient. If I'm integrating from 0 to 0, the answer is just 0. I don't even have to find the antiderivative. What's the area under that curve from 0 to 0 is just 0. So now my whole question depends only on this integral that's in red. Antiderivative of cosine 2 theta will give me sine 2 theta over 2. Now multiply it by the 4 on the outside, and I just have a 2 sine 2 theta. So 2 sine 2 theta evaluated at 2 pi and at 0. Again, something funny happens. I end up with a 0 minus 0, and the answer is 0. So if you guessed 0, you were correct. That is my circulation. What does that mean? We'll go back to the original picture here. It looks reasonable that as much of the vector field is pointing in the direction of the curve as it is pointing away from the curve. Okay, so the circulation here looks to be 0. Now, we have one more thing to calculate, and that is what we call the flux. So the flux tells me whether more vectors are pointing in or pointing out. So it gives me the formula here that the flux is the dot product of the vector field and the normal vector. So we can write it like this, the integral of Fy prime minus g times x prime. If C is a closed curve with a counterclockwise orientation, n is the outward normal vector, the flux gives the outward flux. So if you get a negative value, that means that the vectors pointing in are larger than the vectors that are pointing out. If you have a positive outward flux, that means there's more vectors pointing out than vectors pointing in. So let's take that same curve that we had and try to find the flux to see what we get. All right. What do I need? I need Fy prime minus g x prime. So the f part we already had, right? That was our 2 sine t minus 2 cosine t. What is y prime? Y prime is going to be 2 cosine t, right? Because y is 2 sine t, the derivative of sine is cosine, so times 2 cosine t. Minus, let's steal the g that we had from the previous problem. It was 2 cosine t, and then x prime is going to be negative 2 sine t. So we need to integrate this from 0 to 2 pi. All right, so this gives me 2 sine t cosine t. Actually, it gives me 4 sine t cosine t. Then minus 4 cosine squared t, and then plus 4 cosine t sine t. All right, so out of all this, we can pull out a 4. And, well, let's do this first. Let's make it negative 4 cosine squared t plus 8 cosine t sine t. Then we'll pull a 4 out. So this will give me 4 integral from 0 to 2 pi of negative cosine squared t plus 2 sine t cosine t. Now, can I steal from the previous problem? Hey, why not? Remember in the previous problem, we integrated sine cosine from 0 to 2 pi and we just got 0, right? That would have been the green piece over here. We integrated sine cosine from 0 to 2 pi and just got 0. So I'm going to steal that answer, and I'm going to say that this part here gives me 0. So now I'm left with just the first part. Again, if I take cosine squared t, I can make that 1 plus cosine 2t over 2. So this gives me 4 integral from 0 to 2 pi of negative green expression. So negative 1/2 minus cosine 2t over 2. Right, from here it might be nice to take out that 2 that's on the bottom. So 4 divided by 2 is 2. And why not pull out a negative, actually? So this will give me a negative 2 on the outside, integral of 1 plus cosine 2t, integrate it from 0 to 2 pi, right? So now if I do 4 times a negative half, I get a negative 2. Put the negative 2 on the outside, the 1 on the inside. 4 divided by 2 is 2, so let's pull the negative 2 out, and now I don't have a denominator anymore. All right, so this will give me a negative 2 times t. Integral of cosine is sine, so plus sine of 2t over 2 by the chain rule, evaluated at 2 pi and at 0. So I get negative 2 times 2 pi. You notice that over here, the sine of 4 pi is 0, the sine of 0 is 0. So I get negative 4 pi. What does negative 4 pi mean? That means that the flux is negative. Meaning that the vectors pointing in are larger than the vectors pointing out. And if you go back to the original picture, it might make a little bit more sense now that we actually did the calculations. The vectors pointing in towards the curve, not necessarily in the direction of the curve, but the vectors pointing in towards the curve are larger than the vectors that are pointing away from the curve. So it has a zero circulation that's going in the direction of the curve, but it has a negative flux. And so the last example here we already did, right? Go back to the circulation example and find the flux. We did it. That's the end of the section.